Happy morning to all. Did you learn the previous day portion? Shall I ask some question from the topic? Okay. What is the formula for boron nitride? What is the formula for boron nitride? Bn. Okay, correct answer. How much temperature is applied for the formation of oxide? For the formation of oxide, how much temperature is applied? 900 Kelvin. Okay, correct answer. What is the formula for sodium borate? Formula for sodium borate. Na3BO3. Okay, correct answer. What is the formula for borax? Formula for borax. Na2B4O7 10H2O. Okay. Today learning objectives. To learn about the chemical properties of boric acid. Number 1, action of heat. Number 2, action of ammonia. Number 3, identify the presence of borate radicals. Number 4, formation of boron trifluoride. Number 5, structure of boric acid. Number 6, uses of boric acid. These are the following objectives for today's portion. The first one, action of heat. What is the first one? Action of heat. Boric acid on heating, we get metaboric acid. This metaboric acid on heating, we get tetraboric acid. This tetraboric acid on heating, we get boric anhydride, otherwise boron trioxide. These are the products are obtained. The first one, boric acid on heating, we get metaboric acid. The temperature is 373 Kelvin. What is the formula for boric acid? H3BO3. Boric acid. This boric acid on heating, the temperature is 373 Kelvin. We get metaboric acid. What is the formula for metaboric acid? HBO2 plus water. How can you balance the equation? You can start with number 2 here. Here having 2 boron, so you make it as a 2. Here having 6 oxygen, 2 to 2, 4 plus 2. Now the equation is balanced. In our textbook we have 4 molecules, that is the correct one. Boric acid H3BO3 on heating 373 Kelvin, you get metaboric acid plus water. 4 molecules, 4 boron, here also 4 boron, and the hydrogen is also. This is the metaboric acid. The second step is the metaboric acid is converted into tetraboric acid. The metaboric acid HBO2. What is the formula for tetraboric acid? H2B4O7. Plus water. Is the equation is balanced? No, not balanced. How can you balance the equation? Here having 4 boron, so make it here 4. Now hydrogen, 4 hydrogen, here only 2 and 2. Balance. Oxygen, 4 2s are 8, 7 plus 1 8. Now the equation is balance the temperature. 430 Kelvin. 430 Kelvin. For the metaboric acid, the temperature is 337 Kelvin, 373 Kelvin, and tetraboric acid temperature is 413 Kelvin. Next one, tetraboric acid on heating H2B4O7 on heating we get boric anhydride B2O3 plus water. Is the equation is balanced? No. Here 4 boron, here having 2. So 2 boron, so we have 4 oxygen, correct, and hydrogen is also balanced. The temperature is red hot, here the red hot. So one of the 3-mark question, very important, the 3-mark question. First one, boric acid on heating we get metaboric acid. This metaboric acid on again heating we get tetraboric acid. The tetraboric acid again on red hot we get boric anhydride, otherwise called boron trioxide. Next one, action of ammonia. Next one, the second chemical property is action of ammonia. Here, the boric acid on heating at ammonia, the temperature, boric acid, what is the formula for boric acid? H3BO3. Formula for ammonia, NH3. You get this boron combines with nitrogen, we get boron nitrate, that is Bn. Plus, here we get the water molecules. Hydrogen combines with this oxygen, we get water, H2O. Here the temperature is 800 to 1200 Kelvin. 800 to 1200 Kelvin. Here the boric acid on reacts with ammonia. This boron combines with nitrogen to form boron nitride. The hydrogen combines with OH to form water. How can you balance the equation? Here hydrogen having 3. 3 plus 3 is 6. So make it here 3. Boron 1, nitrogen. Now the equation is balanced. Can you write the equation? Boric acid on reacts with the ammonia, we get boron nitrogen. The temperature is 800 to 1200 Kelvin. The third one is a very important question. How you identify the presence of borate radicals? The third one, very important question, very important. Identify the presence of borate radicals. A very important question. How will you identify the presence of borate radicals? Here we are using boric acid with ethyl alcohol. What is the formula for boric acid? H3BO3 on react with ethyl alcohol, ethyl C2H5OH. Functional group OH for alcohol. Ethyl alcohol. Boric acid on reacts with ethyl alcohol. The presence of concentrated sulfuric acid. Boric acid on react with ethyl alcohol. The presence of concentrated sulfuric acid. We get an extra group that is called trialkyl borate. What's the product? Trialkyl borate. The formula is BOC2H5 thrice. This is the trialkyl borate, the extra group, and also the water is formed, H2O. How can you balance the equation? It's a very important balance the equation. Here the hydrogen, 3 hydrogen combines to OH to form water. Here having 3 ethyl group, 3. So we can make the 3 here. So we get a trialkyl borate ethyl group. Okay, now the equation is not balanced and also having water. 3 hydrogen combines 3 OH. We get 3 molecules of water. 3 molecules of water. What's the name of this product? Trialkyl borates. It's a very important question. So learn the equation. Next one. The formation of boron trifluoride. The formation of boron trifluoride. Formation of boron trifluoride. Here we are taking calcium fluoride. What is the formula for calcium fluoride? CaF2, calcium fluoride. On react with the sulfuric acid, H2SO4 plus boric acid, H3BO3. These are the 3 reagents we are taking: calcium fluoride, sulfuric acid and boric acid. Here the calcium combines with sulfate to form CaSO4. CaSO4. What is CaSO4? Calcium sulfate. Here our product is boron combines with the fluorine. Boron combines with the fluorine, we get BF3. Boron trifluoride. BF3. Boron trifluoride. And also the water is also one, H2O. How can you balance the equation? We can take here calcium. Then we take here calcium as a 3. Calcium. Here also sulfate also. Make it a 3 here. Now that is a balance. About the fluorine, make it a 2 here. Make it 2 here. Also boron 2. Water 2 plus 2 into 3 6. 6 means 6 molecules of water. Now the equation is balanced. Calcium fluoride plus sulfuric acid plus boric acid, we get this calcium combines with sulfate to form calcium sulfate. Boron combines with the fluorine to form boron trifluoride, and also hydrogen combines the OH to form water. First we should be balance the equation. Balance the equation. How can we balance the equation? First 3 calcium, make the 3 here, calcium, 3 over, then sulfate 3, here also make the 3, sulfate also over, and about the boron, here I am 2, to make it a 2 here, and hydrogen 6 plus 6, 12, okay. The next one is about the boron react with or soda, and that is called, you can see sodium carbonate. Boric acid reacts with the sodium carbonate. What is the formula for sodium carbonate? Na2CO3. Boric acid on react has 3BO3. Boric acid on react with sodium carbonate, we get borax. What is the formula for borax? Na2B4O7. Na2B4O7. Here sodium carbonate. Here the sodium combines with boron and oxygen. We get borax. The next product is here carbonate is converted into carbon dioxide. This carbonate CO3 is converted into carbon dioxide, and also the hydrogen combines with the OH to form water. First one, sodium carbonate here the sodium combines with the boron and also oxygen, we get borax. The carbonate is converted into carbon dioxide and also having hydrogen and here having OH to form water. How can we balance the equation? Here having 4 boron, so make it here 4. Sodium, carbonate also. Equation 4 3s are 12. Here having not balanced. How can you balance the equation? You make it at 2 here. So 6 2s are 12, 4 3s are 12. Now hydrogen is also balanced. Next about the structure of boric acid. The structure of boric acid. Boric acid has a two-dimensional layered structure. First point is two-dimensional. Boric acid has two-dimensional layered structure. It consists of borate radicals or borate units BO3. Borate radicals, other units. These are linked by each other with hydrogen bond. Linked by hydrogen bond. These are the 3 important points. Structure of boric acid, two-dimensional layered structure, BO3 3 minus ions unit, and these ions are linked by hydrogen bond. The formula for boric acid is H3BO3. What's the formula for boric acid? H3BO3. Here having 3 elements: hydrogen, boron and oxygen. Whenever you are drawing the diagram, first boron atom is at the center. The boron atom is the boron atom. This boron atom is surrounded by 3 oxygen atoms. That is 1, 2, 3. Boron atom is the center, surrounded by 3 oxygen atoms. Then about the hydrogen. This is for one boric acid. Next boric acid. Boron, oxygen. Boron is the center, 3 oxygen. Then about hydrogen. One hydrogen is over. Next one is next hydrogen. The other one is next hydrogen. Okay, 3 hydrogen is over. Boron is surrounded by 3 oxygen atoms. And also having hydrogen. This is the first molecules of boric acid. This is the second molecules of boric acid. In between the 2 molecules, we have a weak bond. Next boric acid. Started with this hydrogen. Oxygen first. Boron, oxygen. Here I have hydrogen. Boron is the center, surrounded by 3 oxygen atoms. In between this molecule, one of the weak bond, oxygen-hydrogen bond. Okay, one molecule is over, second molecule is also over, third molecule is also over. Next one, start with this oxygen, hydrogen, oxygen, boron, oxygen, hydrogen, hydrogen. In between, oxygen and hydrogen having one of the weak bond. Okay. Here, this is the first molecule of boric acid. First molecule. The second one is second molecule. Third molecule. This is the fourth molecule. Okay. This is a boron atom surrounded by 3 oxygen atom. Then also having hydrogen atom. So each molecule having 3 elements, 3 hydrogen atom, 1 boron atom, and also 3 oxygen atom. One molecule to other molecule having one of the weak bond. This is the structure of boric acid. Next learning objectives to learn about diborane. To learn about diborane. For this having preparation, properties, action of air, hydroboration, reaction with ionic hydrides, reaction with ammonia, structure of diborane and uses of diborane. The first one, preparation of diborane. For the preparation of diborane having a simple concept. How is diborane prepared? That is, the metal hydride with the boron, we get diborane. Metal hydride with the boron, we get diborane. For example, sodium borohydride. Sodium borohydride formula NaBH4. Sodium borohydride. This sodium borohydride on react with small quantity of iodine I2. Small quantity of iodine we get diborane. Formula B2H6. What is the formula for diborane? B2H6. The sodium combines with iodine. The sodium combines with iodine to form NaI. Sodium iodide and the evolution of H2. Okay. What is the first one? Sodium borohydride on react with iodine, we get diborane, B2H6. And the sodium combines with the iodine to form NaI. And also we get hydrogen. How can we balance the equation? Here having 2 boron, here having only 1 boron. So make it 2 here. And also sodium, having 2 sodium, make it 2 sodium. 2 NaI. Now the equation is balanced. Next about magnesium boride. Magnesium boride formula Mg3b. Magnesium boride Mg3b2. Magnesium boride with HCl. We get boranes B4H10. Boranes. This magnesium combines with the chlorine. Magnesium combines with chlorine to form MgCl2 plus H2. Here having 4 boron, here having 2. Then 2 2s are 4. Magnesium 6. Then chlorine 12. 12. Hydrogen 10/2. The equation is balanced. This is a boranes. This boranes on add with hydrogen B4H10. Add with hydrogen, we get diborane B2H6. So here having 4 boron, here having 2 boron, make it 2. Now the equation is balanced. About the physical properties of diborane. It is a colorless diamagnetic compound with low thermal stability. Colorless diamagnetic compound. Second one, it is a gas. It is a gas at room temperature. It is a gas at room temperature. with a sweet smell, with a sweet smell. And also it is extremely toxic. Also extremely toxic. And also having some higher temperature reaction, that you should be take the written practice. If you have any doubt, we will discuss later. Next, diborane reacts with the water to give boric acid. And also diborane reacts with the alkali to form sodium metaborates. Sodium metaborate. First one, boric diborane B2H6. Diborane reacts with water to form boric acid. H3. What is the formula of boric acid? H3BO3 and the evolution of hydrogen gas. How can we balance the equation? 2 boron is there, here having only 1, to make it 2 here. Then about the hydrogen, to make it here 6 molecules of 6 molecules. Next about diborane B2H6 and react with the alkali, that is sodium hydroxide plus water. Sodium hydroxide plus water, we get sodium metaborate NaBO2 plus H2. How can you solve this equation? Here having 2 boron, here having only 1. 2 sodium, 2 sodium. 2, here are the equation 6H2. Now the equation is balanced. Next one, action of air. Action of air. Here, at room temperature, pure diborane does not react with the air or oxygen. At room temperature, pure diborane does not react with the air or oxygen. But the impure form, it gives boron trioxide and also gives a large amount of heat. The heat is about delta H. Delta H is equal to minus of 2165 kilojoules mole inverse. This much amount of heat is liberated with the equation. It's a diborane formula. B2H6 on react with the air to form B2O3. What is B2O3? Boron trioxide with water molecules. Then how can we solve the equation 3? Make it 2 here. Then hydrogen 6, 3 is 2. With the temperature is delta H value is equal to minus 2165 kilojoules mole. Next one, what happens? Diborane reacts with methyl alcohol. What happens? Diborane reacts with methyl alcohol with CH3OH. What is CH3OH? Methyl alcohol. That is diborane formula B2H6 methyl alcohol CH3OH. Methyl alcohol, we get BOCH3 thrice. Trimethyl borate plus hydrogen. Here, this boron combines with methyl group CH3O. We get BOCH3 thrice. The equation balancing 3 methyl group is there, make it 3 here. Boron 2, 2. If the hydrogen is, make it 6. Equation is balanced. Next about hydroboration. Hydroboration. So one of the important question, diborane adds onto alkenes and alkyne in either solvent at a room temperature. This reaction is called hydroboration. For example, we are taking alkene and alkyne. Diboron formula B2H6. Diboron, we are taking alkene RCH, CH, double bond CHR. The double bond means we are taking alkene, we get boron joining there, boron RCH. The double bond is converted into single bond. One of the hydrogen is attached to CH, CH2R, CH2R, and also we can take thrice. So how much boron is there? 2 boron, make it 2. Here has been 6 molecules. This is one of the hydroboration reaction. Next about reaction with ionic hydride. Reaction with ionic hydride. For example, we are taking lithium hydride and sodium hydride. Diboron formula B2H6 on react with the lithium hydride. LiH. Lithium hydride in the presence of ether. What's the product we get? Lithium borohydride formula LiBH4. LiBH4. Here boron 2 having maybe 2 here. How much lithium having? 2 lithium. Make 2 lithium. So the equation is balanced. Next one, diboron. React with the sodium hydride formula NaH. Sodium hydride. So what's the product? NaBH4. Sodium borohydride. Sodium borohydride. Then how much boron is there? 2. Here having 1. So make it 2 here. How much sodium is there? 2 sodium. Make it 2 here. Hydrogen is equation. Hydrogen is 6 plus 2, 8. 2 4s are 8. With ammonia, diboron with excess ammonia at low temperature, it gives diboron ammonate. With low temperature, it gives diboron diammonate. And with high temperature, it gives borosol. Diboron formula B2H6. Diboron on react with ammonia NH3 and the temperature is minus 153 Kelvin. Diboron reacts the ammonia, we get diboron diammonate formula B2H6.2NH3. So we can be balance the equation. Here make it 3, here also make it 3. Now 3 2s are 6 ammonia, it is 6 ammonia. So the equation is balanced. Next about diboron react with B2H6, react the ammonia, high temperature in a closed vessel, high temperature, closed vessel we get a borosol formula, nitrogen structure, boron, nitrogen, boron, nitrogen, boron, nitrogen, hydrogen, 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 hydrogen. This is called borosol. This is called borosol. Next about uses. Uses of diboron. First one, it is used as a high energy fuel for propellant. High energy fuel. Second one, it is used as a reducing agent in organic chemistry. Reducing agent. Reducing agent in organic chemistry. The third one, it is used in a welding torch. These are the uses. Once again, it is used as a high energy fuel for propellant. It is used in reduced agent in organic chemistry, and also it is used in a welding torch. Structure of diborane. The formula for diborane is B2H6. First we are taking boron. Boron, the atomic number of boron is 5. This is boron. This is another one boron. The first shell we can accommodate 2 electrons. The second shell 3 electrons. Second boron, first shell 2 electrons. Second shell 3 electrons. For completely filled 8 electrons needed, but having only 3 electrons. Next I am accommodating hydrogen. Hydrogen, first shell 1 electron. There is a bond between hydrogen and boron. Having total 6 hydrogen, one is over. The second one is hydrogen, having 1 electron in the outermost shell. This bond between hydrogen and boron. Next, third hydrogen. Hydrogen, outermost shell having 1 electrons. There's a bond between hydrogen and boron. For this boron, hydrogen, outermost shell having 1 electron. The bond between hydrogen and boron. Second hydrogen, for second boron, hydrogen, 1 electron, the bond between hydrogen and boron. The third one, hydrogen, the bond between hydrogen and boron. Here, there is for this boron, there is a 2 electron, and also this boron, also this 2 electron can be joined. Here, the boron is covalently bonded to boron and hydrogen. Here also, the boron bond with 2 electrons. Here, this is a covalent bond, covalent bond, covalent bond, covalent bond. First of all, I am drawing the diagram for structure of diborane. First of all, I am drawing the structure of diborane. First, boron, boron, hydrogen, hydrogen, boron, hydrogen, boron, hydrogen, 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 hydrogen. Here in diborane, 2 BH2 units are linked by 2 bridged hydrogen. Here, this is the BH2 unit. This is one of the BH2 unit. This is hydrogen. So BH2 unit. This is another BH2 unit. This is linked two bridged hydrogen. This is two bridged hydrogen. This is one bridge. This is another one bridged hydrogen. Therefore, it has 8 BH bond. 1 BH bond, 2 BH bond, 3 BH bond, 4 BH bond, 5 BH bond, 6 BH bond, 7 BH bond, 8 BH bond. They have 8 BH bond. However, diboron has only 12 valence electrons. These 12 valence electrons are not sufficient to form normal covalent bond. That is, diboron boron, outermost shell having 3 electrons, 1, 2, 3. Each side hydrogen is paired. Hydrogen. There's a bond between hydrogen and boron. Bond between hydrogen and boron. Bond between hydrogen and boron. Another one boron. Boron having 3 electrons in the outermost shell. Hydrogen having 1. Hydrogen having 1. There's a bond between hydrogen boron. There is no covalent bond. There is no sufficient bond for here forming covalent bond. That's the meaning. However, diboron has only 12 valence electrons and are not sufficient to form normal covalent bond. 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 valence electron are not sufficient for normal covalent bond. It is not sufficient for normal covalent bond. The fourth terminal BH bond are normal covalent bonds. This is the normal covalent bond. 1, normal covalent bond 2, normal covalent bond 3 and normal covalent bond 4. Here 2 center 2 electron bond. This normal covalent bond having 2 center 2 electron bond. 2 center means this is one center. This is another center. This center means a bond between hydrogen and boron. That means here having 2 center having each center having 2 electrons. That is 2C 2E. 2 center 2E. The remaining 4 electrons have to be used for bridge bonds. This is the remaining 4 electrons. This is bridge, hydrogen bridge. The remaining 4 electrons have to be used for bridge bond. That is 2, 3 center. That means this is one boron. This is the hydrogen. This is the boron. That is BHB. That is the 3 center. BHB. 3 center. Each center having 2 electrons. Since the boron is a sp3 hybridized. These are all sp3 hybridized. One of the s orbital combines the p orbital to form sp3 hybridized. This is the structure of diboron. Next one, preparation of boron trifluoride. Boron trioxide, B2, O3, boron trioxide on react with calcium fluoride. Calcium fluoride, the presence of sulfuric acid. Boron trioxide on react with the calcium fluoride, the presence of sulfuric acid, we get BF3. That is called boron trifluoride plus calcium combines with sulfate to form CaSO4 plus water. Then we can balance the equation. Here having boron 2, here having boron 1. So make it 2 here. Next about the fluorine. Here having 6 fluorine, then calcium 3, sulfate also 3. Next about the water, make it a 3. Now the equation is balanced. Next one, by the treatment between B2O3, boron trioxide with carbon plus fluorine. Boron trioxide plus carbon and fluorine, we get boron trifluoride plus carbon monoxide. How can we balance the equation? Here having 3 oxygen, here having 1 oxygen. Make it 3 here. So 3 carbon, boron 2, BF3, and also fluorine 3. Equation is balanced. Next about benzene diazonium tetrafluoroborate. Benzene diazonium tetrafluoroborate, otherwise called phenyl diazonium tetrafluoroborate. This on heating we get BF3, boron 3. And also one of the phenyl combines with the fluorine, we get PHF plus nitrogen. This is one of the important question. Benzene, otherwise phenyl diazonium tetrafluoroborate, on heating we get boron trifluoride. And for example, another one example, phenyl can be used benzene C6H5N2BF4. We get BF3 plus C6H5F plus N2. This is another one example. Next, what are the properties of boron trifluoride? What are the properties? First one, it has a planar geometry. It is an electron deficient compound. It accepts a pair of electrons to form a coordinate covalent bond. Very, very important point. It accepts a pair of electrons to form a coordinate covalent bond. For example, BF3 boron trifluoride on reacts with ammonia, NH3. Boron trifluoride on reacts with ammonia, we get and here nitrogen gives a pair of electron. Nitrogen gives a pair of electron to boron. This is a coordinate covalent bond. Nitrogen gives a pair of electron to boron. So it is an electron deficient compound. Another more example, BF3 plus H2O. We get F3BOH2. Here oxygen gives a pair of electron to boron. On hydrolysis, boron trifluoride gives boric acid. This boric acid gives fluoroboric acid. Next equation, BF3 boron trifluoride undergoes adding water, that is hydrolysis. We get boric acid H3BO3 and this hydrogen combines the fluorine to form HF. Here, boron, we can use this boron 4BF3, and here also we can use 4. Then hydrogen 12, we can use 12 here, and here also 12. Equation is balanced. Then about boric acid, H3BO3, boric acid, on react with hydrogen fluoride, we get H plus ions, and also fluoroboric acid BF3, BF4 minus plus including water. Balance the equation, make it 3 here. So here also 3H plus and 3 fluoroboric acid, and also here 12 hydrogen fluoride, here also 9. What is the overall reaction? Here we should be cut the boric acid, one more heavy here, and 12 H fluoride, and water 12, here having 9, remaining 3 more heavy. What's the remaining? Remaining means 4BF3 plus, here having again 3 more having, plus 3H2O gives 3H plus 3BF4 minus, and also H3BO3. One more here, one more H3BO3. 3 and 3 cut, one more H3BO3. Next, about the uses of boron trifluoride. It is preparing for HBF4 compound. It is preparing for HBF4 compound. It is used as a catalyst in organic chemistry, and also it is used as a fluorinating reagent. It is also used as a fluorinating reagent. Okay, for today assignment, write the preparation, properties and chemical reactions of diborane. Write the preparation, properties and chemical reactions of diborane. Thank you all of you. Thank you. May God bless you.